Hello and welcome back to the course on R programming. In today's tutorial we're talking about the dollar sign. So what is it all about and what does that operator do? Well, we'll find out just now. Let's create a new section in our code, and here we'll say using the dollar sign. Alright, so first of all, let's look at our data, right? Stats. That's quite a lot. Let's use one of those functions that we learned previously, head stats. So here we get our first 6 rows, our top 6 rows. Great. So how could we, for instance, select a row from here? How could we select this row, for instance, Angola, and we want to extract the birth rate for Angola? Well, working with a data frame is very similar to working with a matrix. So we would say stats, square brackets, and Angola is in the 3rd row, right? So 1, 2, and in which column? A 3rd column. So we would say Angola 3, 3. That would give us 45,985. There we go. That's the same number that we were after. All right. What other ways are there? Well, from our previous section, we know about named objects, and we can see that this is a named object. It has these column names. So we can use the column names. So we can say 3rd row, and then instead of the number of the column, we can say birth rate, right? So we can say birth rate. Now if we run that, we get the same number. Great. Now what we can't do is we can't say stats, basically then 3 here, but then say Angola. We can't do that. Why can't we do that? Because, of course, this is a column in the dataset. It's not the name of the row. It's just a column in the dataset. If we run that, we'll get an NA. That's not found. The value was not found. And we can't do that because even though it looks like they're at the start and maybe we can use them to index things, actually not. It's just simply a column. It could have been on the right. It could have been anywhere. So you can't do that. And that makes sense, right? Because in a data frame, the rows are numbered and they don't have names. The columns have names, but rows don't. Rows have numbers. And that is very similar. If you think about it, it's exactly the same as in Excel, right? In Excel, you have columns with names, but you don't have names for rows, right? So it totally makes sense when you think about it that way. All right, so what are we talking about today? What is this dollar sign? Well, the dollar sign is another way to access your data in a data frame. Dollar sign doesn't work for matrices, but it does work for data frames. So what you would do is you'd say stats, and you would type in dollar sign, and then you can select any one of your columns. So let's say internet users. You see, it's giving me a pop-up, so I can select it like that, or just click enter. And what that will do, if I run this now, it will just return me this whole column of internet users. So let's run that, and you can see that it's just a huge vector. It's returned me a vector with all of this information. So it's basically extracted that vector. And what I can do now is I can find a value in that vector. Let's say I want to access the 2nd row in the data frame. That would become the 2nd value in the vector, and I would just look at it like that, right? So it's 5.9. If I look back at my data set, you'll see 2nd row, 5.9. So that's the internet users in Afghanistan. Okay, so basically, we've extracted a whole column from this data set. That is very similar, or that's exactly the same thing as we used to do. Remember, we would say comma, nothing, right? So that means we want all of the rows, and then we would use the name of the column or the number of the column in quotation marks, right? Same thing, we get the same result. So basically, this operation is identical to this operation, right? So it's just a more convenient way. You can see that putting a dollar sign and then typing the name of the column is more convenient than typing in all these square brackets. And so that is just one of the ways you would use the dollar sign, so to extract a vector and then access the value. This is not the most common usage of the dollar sign, and it's just to kind of help you get your head around what's going on here, that basically a dollar sign specifies the columns that you want. And you'll see throughout this course that the dollar sign is very handy when working with data frames, and we'll be using it a lot, and you will see it a lot in R. So we'll get used to it with time, but for now it's just good that we have this understanding. And I just wanted to show you one more application of the dollar sign before we move on to the next tutorial. Remember in the previous tutorial we talked about factors. So if I run this line with the, or str, so the structure of the data frame, you'll see that here we've got factors, right, with levels. But here, from here, we couldn't tell what are the factors. We know there's 4 of them, and we know that one of them is high income. What are the other factors here? Well, there's a function that can help you with that, and the function is called levels. Pretty straightforward, isn't it? Because it says here with 4 levels, so you can just basically copy that word from here, and then there's your function. Don't even need to remember it. And levels, for the factors, you need to supply the name of the column, right? So you would say stats, and now you need to somehow get to the column to feed it to this function, because it can't tell you the levels for the whole data frame. You have to say which column you're interested in. How do we get to the column? Well, easy. We know the dollar sign now, and we'll just say dollar sign and income group. And now we'll run this line, and you can see now it prints us out the factors. It actually puts them into a vector, so you can then assign this to a object if you want and create a new vector with these 4 values. But basically we can see them on the screen: high income, low income, lower middle income, and upper middle income. There we go. That's how you use the levels function, and most importantly, that's how you use the dollar sign. As you can see here, it is already very quick, much more quicker than typing this up. Okay, this brings us to the end of today's tutorial, and I look forward to seeing you next time. Until then, happy coding! Hello and welcome back to the course on R programming. Today we're talking about basic operations with a data frame. Okay, so we already know the dollar sign, and that will come in handy today. That's a good start. Let's look at what we can do with a data frame. So here I'll just type in basic operations with a data frame. So I'm just going to say DF for data frame. All right, so what are we going to start with? Well, we're going to start with the most probably common thing that you might want to do with a data frame is subsetting. So we already know about subsetting from matrices, right? And some of those things we know, or probably all of them, will come in handy today. So let's say we want to look at stats, but we want to look at only the first 10 rows. How would we do it? We would say that. We would say stats, and then we would say in square brackets 1 to 10, comma, nothing, right? That means the first 10 rows and all of the columns, because there's nothing here. So if we run that, you will see we've got 10 rows and all of the columns, right? So I could have, that is, let's type in a comment, subsetting. I could have done a similar thing. I could have said stats, and I could have said the 3rd to the 9th, comma, nothing, right? Or another one that we already know is we want to look at specific rows. We want to look at the 4th row and the 100th row, comma, nothing. See, we've got the 4th and 100, and you can see that every time the numbers of the rows are maintained, or they're preserved. So that preserves the structure of the data set. So basically it doesn't change to 1 and 2, it stays 4th and 100th. So then you can know where these rows came from in the original data set. All right, so that's subsetting. And now let's remember one thing that we talked about previously is, let's say, remember how the square brackets work, right? Let's type in some examples. Let's say we want to look at stats and we only want to look at the first row, right? If we run that, yep, we get the first row. And what do we get here? Well, remember in a matrix, when we extracted just one row, what it would do is it would get rid of the name here, and it would drop a dimension, basically turn the row into a vector, right? Does that happen in a data frame? It doesn't look like it because the row number is still here, so it looks like this is still a data frame. So let's quickly check that. We have a function is data frame. They're pretty straightforward, all of these functions, is and then dot whatever you're asking about. And so if you run that, you will see that it's true. So in a matrix, if you extract one row, it will turn into a vector. In a data frame, if you extract one row, it stays as a data frame. So there's no need for that secret parameter that we know about, drop false, right? So let's look at another example. Let's say we want to extract stats and we want to extract just the first column. So in this case, what are we extracting? We're extracting the country names. And this time looks like this is no longer a data frame. Looks like this is a vector that has been printed for us out onto multiple lines, right? So let's quickly check, is this a data frame? So just to be sure, and close that. So you can see that it's not a data frame anymore. So if we want to preserve it as a data frame, what are we going to do? We're going to say stats, and then we're going to say comma 1, and then we'll say comma drop equals false. That way the dimension won't be dropped, and if we run that, you can see that this is now a data frame, and it just has one column. So same thing, we can confirm that this is a data frame by just simply running the isDataFrame function. Run that, you can see that now it's true, it is a data frame. Okay, that's important to remember, because so it's the same concept of dimensions being dropped, but it only applies when you're extracting a column. So always check that just to make sure that you are working with what you want. Now what we're going to do is we're going to look at some mathematical operations. So let's say we want to look at, let's check out our data frame. We can see that we've got two numeric values. Let's just multiply them. I know it makes no sense to multiply birth rate by internet users, but just to prove a point that we can do that, let's check it out. So we'll say stats $, this is the $, coming in handy, birth rate multiplied by stats $, internet users, right? So if I run that, we'll get the result of that in a vector. Same thing, I can add, subtract, multiply. Let's add these two. Now we've got the addition of the two. All right, so pretty useless operation right now, because there's no point in doing it, but it's good to know that you can do that. The next thing I wanted to show you, and this is, we're still on the topic of basic operations with data frames, is adding a column. So you might want to add a column to your data frame, right? So how would you do that? Well, let's look at our data frame. You can see that here it's got only 5 columns. To add a column, what I would do is I would say, it's very simple. I would say stats, and then I would just pretend that the column is already there. I would say stats $, and let's call the column my calc, right? For my super awesome calculation, which has no meaning. And I'll just copy this in here, and then I'll run this line. And now if I run head stats, you'll see that now I've got this extra column where it has, the values have been multiplied. And take note here that these are still vectorized operations. So everything we're doing is happening on that fundamental rule that everything is a vector and everything is happening in vectorized form. So when you multiply birth rate by internet users, R knows that you want to multiply this value by this value, and it gives you that value. Then this value is multiplied by this value, you get that value. So a vector is multiplied by a vector. Everything is happening in vectorized form, and that's why vectorized operations are so important in R. All right, so that's how you add a column. Now I wanted to actually test your knowledge. Test of knowledge. Let's say I want to add a column, stats, right, XYZ, but I'll add a column with only a vector that only has 5 values. So I'm going to add a vector of 5 values into a matrix, or into a data frame that has 195 rows. What will happen now? Can you tell me what will happen? So will there be an error? Well, there isn't an error. Why isn't there an error? Let's check it out. If you look at head stats, what you'll see is 1, 2, 3, 4, 5, 1. What does that 1 stand for? What does that mean? Let's look at a few more. Let's say head stats n equals 10. What you can see is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and I guarantee if you type in more, 12, let's say, it just keeps going 1, 2. So what happened here is the vector 1 to 5 was recycled. And we talked about this way back, I think it was in section 2, that when you try to perform an operation where a vector is insufficient length, it gets recycled, right? But the important thing is that this vector, or this vector, has to be a multiple of this vector. So if, for instance, I type in here 1 to 4, right, which 195 is not a multiple of 4, I run that, you will see I'll get an error, because R can't recycle that vector, and it's telling you about that. So there you go, that's just a blast from the past, or a test of your knowledge, and just make sure you remember about recycling of vectors in vectorized operations, because that can occur sometimes without you even intending it on or remembering about it. So now the last thing we want to look at is remove a column. How do you remove a column? Now that I have these columns, stats, let's look at head stats. How do I remove these columns that I don't want? It's very simple. You say stats, $, and then the column name, and all you have to do is assign it the value of null. Remember how we used to get rid of names in named objects? Similar concept. And let's get another one. Here we will say X, Y, Z, get rid of it. And now if I check out head stats, you'll see that no more columns. There are a couple of ways to get rid of columns in R, but this is by far the fastest and easiest one. So let's just stick to that one, and you will learn new ways. We do that quite a lot in this course. Like, I show you the main concept, and you will pick up other concepts as you go along, as you get to know the language better. I don't want to bombard and overwhelm you with all this information. We're just learning. We're on a journey, right? We're on a journey, and we're learning what we need to go through this journey and have fun and make it exciting. So if you want to get rid of a column, just use this way. It's the fastest and easiest one to use. All right, that brings us to the end of today's tutorial. I hope you enjoyed these basic operations with data frames. As you can see, we're slowly building this knowledge on data frames, and in this tutorial I actually encourage you to take a break and actually practice what you've learned, do some of your operations, switch your imagination on, try some different operations here, mathematical operators and so on. So just practice this stuff and let that knowledge sink in, and I'll see you on the next tutorial. Until then, happy coding! Hello and welcome back to the course on R programming. I hope you had a chance to practice what we talked about last time, and specifically basic operations in a data frame. And today we're talking about filtering data frames. All right, let's get started. I'm going to copy this and create a new section in our code, and this one we will call filtering data frames. All right. In the previous section, we mostly talked about working with columns, right? Except for at the very start where we talked about the square brackets, but then we were mostly working with columns. Column multiplied by column, create column, then recycling of vectors for columns or into columns, and then also deleting columns. But filtering is actually more about rows, right? So like if you think about it in Excel terms, right? You've got a table and you want to look at only specific rows. Then you switch the filters on, the columns are still in place, but some rows are hidden, some rows become visible. Or you want to, switch off, like delete some rows. So that's also a filtering and so on. So working with rows. How do we do it in R? Well, the first thing that I'm going to show you is a pretty cool feature, or a cool approach is, let's say I want to look at stats. So let's start with head stats. This is becoming a very used function, head stats, because we're using it in every tutorial. I'm sure you'll remember it after this section. So head stats, and let's say we want to look at internet users. Let's say we want to look at internet users, and so we would say stats $internet users, right? So that's that column. Now let's say we want to find out which internet users or which countries have less than 2 internet users, less than 2% of people using internet. We would say stats internet users, remember this is a vector, and then we're comparing it with the number 2. And what that will give us is it will compare every single value in this vector with the number 2. So let's run that. You will see that we've got this vector of false, 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 and then there's a true here. False, 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 and so on and so on. There's another true. There's another true. So every time it comes across a value that's less than 2, it'll put a true. Otherwise, it'll be false. Okay, so in return, we've got a vector. And what can we do with this vector now? Well, we can put this vector into an object. And let's call that object filter. If we run this, now we've got an object filter, which looks exactly like that. What can we do with this filter? Well, what we can do is we can go to stats, and then in square brackets, and this is the cool feature I was talking about. In stats, you can say in the rows, you know how we used to say 1 to 10, right? Or 1 to 100, right? We want to see the first 100 rows. Well, now what we're going to do is instead of saying 1 to 100, we're going to say filter. And that will pass, and this is the important part that we have to understand, that stats will take a vector which is exactly the same length as the data frame, but this vector is a true-false vector. So every time it will come across a true, it will display that row. Every time it comes across a false, it won't display that row. So if we run that, you'll see that we've got only selected rows, and they all do indeed have less than 2 internet users. So these countries, they don't have, the internet is not that widespread, and therefore only a couple, like around 1% of the population actually uses the internet there or has access to the internet. And how did we get that? Once again, we have a vector with true false values, and this data frame, the way we're calling it or the way we're accessing it, every time it comes across a true value, it will display that row. Every time it comes across a false value, it won't display that row. Okay, that's filtering. So that's a very neat feature to remember and use. And now we're going to actually not just use it, we're going to abuse it. So let's start doing that. Stats, and now what we're going to do is, let's say we want to look at countries with birth rate over 40. Remember, we looked in the STR from the STR function, we know that it's never over 50, but let's look at the countries with over 40. How would we do that? Well, we would use a similar approach, but this time we're not even going to create the filter. We're going to just take this, right? And we're going to put a comma, and we're going to, instead of doing this intermediary step, we'll just put it right in here. And now we'll just change the condition, greater than 40, and not internet users. We want a different column. What's the column that we want? Birth rate. Birth rate. There we go. So if I run this now, I will get all of the countries that have a birth rate over 40. That means per 1,000 people, 40 people, at least 40 people are born every year. Well, basically, those countries, their population is growing very quickly. There we go. That was that easy, and that is thanks to the new approach that we learned, that not always you have to just pass the numbers that you want to display, the row numbers, but you can actually supply a true-false vector, and it will tell you. The data frame will return the rows that are associated with the true values in your vector. All right. So now what we're going to do is we're going to make this condition even more interesting. We're going to say where countries with birth rate over 40, but now out of these, we want to select only the countries with internet users under 2. So we will add the and remember it's a single and, unlike some other programming languages, stats $, and then internet users less than 2, right? So now both of these conditions have to be true for the row to show up. If we run that, now we've got just 3 rows. 1 to 3 countries, all of them have a birth rate over 40 and internet users under 2. Awesome. What else can we do? Well, let's filter by categorical variable. One of these. Let's look at income group. Oh, well, actually, we only have one proper categorical variable. These are just the country names and so on. So let's filter by income group. And now we will say stats $ income group equals, so double equals, let's remember that. And let's say we want to look at all the high income countries. And don't forget the comma nothing. All right, let's run that. Okay, you see I made a mistake. I made a mistake in my code. That's why I got an empty result. So high income, no incomes. If we run that, there we go. So we can see all of the countries with high income. You can see on the right, they're all high income. Okay, that's good. And so we know about factors. We've already talked about factors. If you want to check a different one, then you can always use levels, right? And stats income group to find out what the factors are. If you want to try out a different one, and then you can try lower middle income just out of curiosity and or just to experiment. And the other thing that I wanted to do is I wanted to give you an exercise. So it's kind of like a brain teaser, and we'll solve it right away here as well. So try finding, can you find out all of the information from this data frame about Malta? So Malta is a country. Try find this information. So use what you've learned here. It's going to be a bit different. You need to make a little change. And can you find, please, the information from Malta? So pause this video and give it a go. And in 3, 2, 1, we're going to solve it together. All right. So the way to solve it is stats. And then here you want to filter by country name, right? Country name equals Malta, comma nothing. If I run that, I get that one row where country name equals Malta. So they have a birth rate of 9.5, internet users 68.9, then they're in the high income group. There we go. That's how you filter data frames. I hope this information was useful and hopefully not too complicated. There is actually nothing complicated about it. It's just we introduced a new concept where you can pass a vector of true false values into your data frame to find the correct values. I know like here it looks a bit complicated. You're calling the data frame and then you're calling it again. But when you think of it in these terms, that first you're creating the vector and then you're passing it into the data frame. It's all pretty simple, but this is a very powerful approach and you will be using it a lot in R. So it was good that we covered it off. And now we're going to move on to the next tutorial. I look forward to seeing you there. And until next time, happy coding. Hello and welcome back to the course on R programming. In the previous couple of tutorials, we learned so much about data frames that we are now ready to proceed to the fun stuff, to visualization. We can finally start visualizing our results. And today we'll learn a brand new function, a very powerful function, which is called QPLOT. All right, so let me introduce you to QPLOT. I'm going to create a new section in our code and I'm going to say introduction to QPLOT. All right, so where do you find QPLOT? Well, if you just type in QPLOT and you type in the question mark, nothing will happen because no documentation for QPLOT, couldn't find it, not there. Where did it go? Well, in order to get QPLOT, you need to install a package. We've talked about this package already a little bit. It's called the ggplot2 package. Let's go ahead. If you don't have it, then you need to type in install packages and in quotation marks ggplot2. I'm not going to do that. I'm going to comment out this line. And if you're not sure if you have it, then just try this line first, library ggplot2. And if I run this, here what you get is I've installed ggplot2 and I get this interesting new comment. Is a great place to get help. Okay, well, ggplot2 is installed. If you got an error, then you might need to first actually download the package and then run this line. So basically just run this line, it'll download the package onto your machine and then you can install the library. All right, so, and we talked about this in the libraries tutorial way back. Okay, so hopefully you've got that sorted and now you have ggplot2. And now if you check QPLOT, whoops, question mark. If you check QPLOT, you will see that the help has updated. So let's zoom in over here. We can see that we've got the QPLOT function. It's got lots and lots of parameters. We are not going to go through them right now one by one. Actually, instead, we're going to start practicing. What's a better way to learn than to practice, right? So instead of just reading this boring theory, let's go ahead and start building and we'll learn as we go. All right, what do we want to visualize? Well, today is just an introduction to QPLOT, so we're not actually solving the challenge. We're just going to use our dataset to do a little bit of experimenting with QPLOT. All right, so let's say QPLOT, and then in brackets, what we want to type is just two things. First, we'll say data equals stats. So what we're doing here is we're saying, okay, QPLOT, I'm passing you some data, and that data is this data frame stats. So QPLOT and ggplot, which are both functions from this library, they both work with data frames. And finally, now that we know data frames, we can finally work with these functions. And because they're so powerful and so good, it's great that we can work with them finally. So basically, we're saying QPLOT, here's some data. It's called this data frame stats. Take it, and everything I type in further down in these brackets will relate to this data set. Okay, QPLOT says okay, because it knows that when you say data equals something, that means that from now on, this is the data that we're working with. Great, so we're kind of encapsulating or creating this shell for QPLOT to work inside. Next, we're saying X equals internet users. Internet. The only problem here is that the pop-up doesn't come back up. So what you see here is we no longer need to say stats $internet users, because now QPLOT knows that everything we type will have this at the start. We don't need to say it. You could say it. You could type in stats $, but it is advised against that. So even in his book, Hadley Wickham, who came up with this package, and we'll talk more about ggplot2 further in the future sections of this course, but basically he advises against doing that once you've set the data set, just stick to it and just use the column names without any dollar signs. All right, so what happens if I run this line? Wow, something already appeared. It's a distribution, and here we've got the internet users. So how many countries fall into these bins? And the beauty about QPLOT and everything in ggplot2 is a lot of stuff is done automatically for you. So the labels for the axes have been added. So here you've got internet users, here you've got count, and then the colors have been selected. You can see a grid in the background. The bins have been selected. You didn't need to do anything. You just wrote one line, and what we got is this beautiful plot right away. Okay, so that's a great start. Let's try something else. Let's say QPLOT data equals stats, and then comma x equals income group, right? And then we'll say y equals birth rate. So what are we doing here? Well, we're saying put a categorical variable income group, so there'll be categories on the x-axis, and put a numeric variable on the y-axis. So let's run that. What will QPLOT do in this case? Wow, isn't that smart? It's already picked the right representation for this combination of data. Okay, what else can we do? We can take this and we can pass in another parameter. We can say size equals 3. Now, let's see what happens if I run it like this right now. You will see that the size did change, but then on the right there's a legend. Why do we have a legend if I just wanted to change the size? What if I change the size to 10 now, if I run that? What you'll see is that they're the same size still. And what's going on is that we are, instead of just assigning the value to this parameter, we're mapping it. So QPLOT is kind of thinking that this is going to, it needs to create a legend, and different objects will have different sizes on this plot and so on. So the correct way to work with QPLOT is you need to put I around the value that you want to assign. So we won't go into detail around why this is, because that would take quite a while to understand. And in fact, we're just working with QPLOT as a transitional step to get to ggplot in further sections of the course. So for now, if you just want to assign a value, say a color red, or a size to your objects on a plot using QPLOT, just type the letter I around it. So that way QPLOT or R will treat this number as is, instead of thinking that it should be mapped to the data. Okay, so let's just run that. And so here you'll see that there's no more legend, and these values are huge, right? These circles are huge. So let's take them back to a value of 3. All right, what else can we do with QPLOT? And once again, this is a tutorial just to get a quick overview of QPLOT and intro to QPLOT. So color, maybe let's make a new line here. I'll leave the comma here on this line, and then I'll say color equals I, and around I I'll say, inside I I'll say blue. Right, so if I run, so I'll share again, if I don't say I, and I run this, and now it's waiting for the second line because of the comma and this plus sign over here. So if I run this, you see that's not blue. That's nowhere near blue. It is a color, but it's not blue. So make sure to put that I when you're working with QPLOT. Okay, if I run that, there we go, we've got blue. Beautiful. So you can control color. By the way, both American and Australian, I'm going to say Australian in this case, British, of course, British English work. So you can type the U, or you don't have to type the U, whatever is your preference. I like typing the U. Okay, and another one is, let's do the same thing. No color, but this time, and actually no size, but this time we'll pass a parameter. We'll say geom equals box plot. So we all know what box plots are. So if I run that, there you go. QPLOT has created a box plot for you. You didn't have to do anything. You just told it, I want a box plot, create a box plot for you. That's how smart this function is, and that is what we are going to be working with in this section. And actually, how about this? How about what we're going to do in the next tutorial is we're going to, visualize what we're supposed to according to the challenge. But why don't you give it a go and see if you can get it to achieve what we're after. And in the next tutorial, we'll do it together, and then you can compare your result. All right, and I look forward to seeing you then. Until next time, happy coding.